This video is entitled Common Diagrams, and it goes along with Chapter 10 in the Project Management for Technology course. I'm James Reneau Ph.D., and I'll be taking you through these common diagrams. In this video, again, I'll be showing you some very common diagrams used in business and specifically in project management. There's the histogram, the fishbone diagram, also known as the Ishikawa. There's the pareto diagram, the run chart, and the scatter chart. The histogram is a type of bar chart that compares the frequency of something against the dependent variable. In this example, usually frequency is on the y-axis and the dependent variable is on the x-axis. In this example, I rolled 1,000 I rolled 1,000 pairs of dice and added up the number of spots. And you can see that after 1,000 die rolls, I had approximately, just over 160 um, sevens. And I had between 30 and 40 twos and 12s. No, they're not exactly the same because this is based upon observation of 1,000 rolls and not the exact statistical possibilities. But a histogram is a good way to see the frequency of an occurrence versus something that occurs. The fishbone diagram, also known as the Ishikawa diagram, is a way to model cause and effects, and it's used in brainstorming. Stop and take a look at the shape beside me. It kind of does look like a fish with its backbone and then bones coming off and then smaller bones coming off in the directions. It's used to talk about problems and problem solving and trying to look at the root causes of problems. So we have a restaurant example here where we're having a problem with cold food. Well, in a restaurant, there are three big bones. Well, there's the big bone coming in, but there are three big things. It could be a kitchen problem, it could be a server problem, or it could be a problem with the restaurant building the house itself. Um, so what so we sat down and thought, okay, well, what are the possible kitchen problems? Well, too many orders. The kitchen can't handle it. The kitchen's not temperaturing, not using the temperature sensors on the food. The kitchen's not punching the food in and out of the system to tell the waitresses or waiters that it's waiting. So that would explain cold food. Well, what server things could cause cold food? Well, a server being inattentive, a server having too many tables, a server not being notified of the food being out. Well, those were all things that could possibly be a server problem. And maybe on in the house side, the restaurant's just too cold. You can't serve warm food in an ice box or in a refrigerator. So you can see that this is a way to help problem shoot and to help troubleshoot and to help brainstorm and look for classes of problems. Is there another big class of problem group that we need to add? I don't know, but there's just a thought of how to use the Ishikawa or fishbone diagram to look for the root problems of cause or root cause of problems. A run chart shows the total over periods of time. So it kind of shows a running total of where we are. Here you can see, for instance, that I'm doing this for a group of agile project management system group working on a development where we've so far done 8 sprints. And each sprint, we've gotten so many features added to the software. And you can see at the end of sprint 1, we had 5 features. The end of sprint 2, it looks like we had 7. At the end of sprint 3, well, we only got one more feature done. Ugh. But at least we got a feature done. So you can see that we're at 8. But look, we're at 15 at the end of the 4th sprint. And we're all the way up above 20. We're at 26, 27 at the end of the 8th sprint. But you can see kind of over time the fluctuations, but you can also see what we're getting done. It's a run chart. The next type of document or next type of diagram I want to show is something called a pareto chart. What a pareto chart shows are a dependent variable and the independent variable So here in this example would be defects on the x-axis and the defect frequency or percent or some other calculation of defects or the independent variable there on the y-axis. And usually it's sorted from the largest to the smallest. So it's kind of like a histogram, but um, this extra line represents the sum of the defects or the cumulative defects here. It could also be a percentage, percent of the percentage running total of them. So you can see that A represents about half, a little bit under half of the total defects, where A and B represent, um, about 17 of 27, or almost two-thirds. So you can kind of see if you solve problem G or problem F here on the pareto chart, you're not going to bend the curve much. But if you can do some of the easy things, some of the big things, you can watch that curve change. So a pareto chart compares a histogram like chart sorted from biggest to smallest to a run chart that runs the percent of the total or the cumulative total, percent of cumulative. The last diagram I want to show is the scatter chart. And a scatter chart is where we have multiple independent variables and dependent variables. And we use it to look to see if maybe there's a correlation. Remember always that correlation does not show causality in all cases. Just because they're correlated doesn't mean there's a cause. But look here at this chart for my employees at Jimco Inc., or my theoretical company. And I have the employee age along the bottom, the dependent variable, and the independent variable of years at Jimco Inc. So I can see that, yeah, there does appear to be kind of a line going up this way through the data. Um, but it's not very closely grouped. I bet the standard deviation would be pretty large between them. So years of employment at Jimco versus the employee age. Well, just thinking the reason that employees that are older have been working with Jimco longer is because they've been alive longer, but been with the company longer. But and you can see the 25-year-old is a relatively recent hire. So there you can kind of see a scatter chart and kind of look for those inferences, kind of look for those correlations that may exist. These diagrams, well, the idea for these diagrams came from Kim Heldman's CompTIA Project Plus study guide. The reference is here. And I would like to say thank you for watching. Remember, this presentation is copyright 2020 by James Reneau Ph.D. You can contact me at jreneau@shawnee.edu. This work is licensed under a Creative Commons Attribution, Non-Commercial Share Alike 4.0 International License, and I would like to say thank you for watching.